This meeting is being recorded.
In section 2.5, we take a look at how to identify lone pairs in a bond line structure. So we'll take a look down here and we see this ion shown here. It has a charge, so it's not just a molecule, it's an ion. And we see this formal charge of -1 on the oxygen. So what we need to infer is the number of lone pair electrons that would exist on this oxygen. Because it's not always included. These lone pairs are often not included on bond line structures. We know that Lewis structures use them or include them, but sometimes we see a bond line structure like over here. But the formal charge, this -1 charge, would always be shown. So we have to infer that on this oxygen, we have 3 lone pairs. And if we wanted to confirm this with a calculation, we know that our formal charge, we'll say for oxygen, for O here, we can solve by the number of valence electrons. So 6th group of the periodic table, 6 valence electrons to be neutral. So 6 minus, it has the 1 bond and 3 lone pairs. So we add each one of these, so 6 plus the 1 electron from the bond here. So we get 6 minus 7, right? So we have an oxygen anion, would have 7 electrons total. So we get that -1 formal charge. So again, the formal charge will always be shown, but the lone pairs are optional and they are implied based on the formal charge. So when we have a negative formal charge on oxygen, when oxygen has 7 valence electrons, right? So we'll see 1 bond and 3 lone pairs in this scenario. So if you want to memorize that when you see this -1 formal charge, you should imagine the oxygen looks like this with 3 lone pairs. When we have a neutral oxygen, we have 6 valence electrons. So no charge results because we have 2 bonds and 2 lone pairs. So if we did the calculation, we would see 6 minus 6, right? The 4 valence electrons and then 2 bonds, 2 more. So 6 minus 6 gives us no charge. Then we have, in our last case here, when we end up with only 5 valence electrons, that would result when we have 3 bonding pairs, 3 bonds, and then 1 lone pair. So you can see something like this over here on next to the oxygen on this OH2 group here. We have a +1 formal charge, and we see that over here expanded out. So we see the 1 lone pair and the +1 formal charge. We can memorize the neutral state of nitrogen as well. So I like to use water. I forgot to mention I like to use water here, right? Because water, we know, we memorize this molecular structure, right? So we know 2 bonds, 2 lone pairs, neutral oxygen. Here I like to use ammonia as my memory device. I have 3 bonding pairs, 1 lone pair, so I have 5 valence electrons. So that's when I have no charge, 3 bonds, 1 lone pair. When nitrogen only has when it has an extra electron, 6 valence electrons, we would then see only 2 bonds, but an extra lone pair, 2 lone pairs now. So we would have 5 minus 6, right, with our formal charge, so a -1 would result. On our formal charge calculation over here, from 4 bonds and no lone pairs would be 5 minus 4, so that's what gives us the +1 formal charge. So that's everything for this section. We'll continue with another form of notation in section 2.6.